Hello folks. Well, yesterday we did the audio line 345 base station. Today from a different customer we've got a rather scruffy late version Uniden 200 and nailed to it is this ridiculous echo thing which will go back to him untested. Unbelievable, isn't it? So we'll cut the carpet tape. Right, first thing we need to do with it being a Uniden is change the 4 capacitors before powering it up. What I don't want to do is wreck either the MB3712 audio IC, which are expensive, nor do I want to wreck the 9119, isn't it, the synthesizer chip. And let's hope this hasn't had any daft modifications. It's slightly worrying because I just start to think that people who tape echo boxes to things may also be into other silly things, like illegal modifications. So I'd hate to be able to have to send this back untouched. So this gentleman, we did 2 Amstrads for him a couple of weeks back, and you will find this is much less sensitive than the Amstrads. There's a diode there. I don't know why there's a diode there. God, it's been fagged on, hasn't it? Let's just hope that somebody hasn't altered the wiring to some other standard. I don't think I've seen the late version in such a state as this one. I always thought these were crystal filtered, but I can't, unless... Surely that's the reference crystal. Oh yeah, there's a crystal filter. Yeah, I thought so. Just check there's no roughness, which is fine. That capacitor, you can see, has been so hot from either being overvolted or its own failure that its heat shrink covering is receding. So as ever we need to change 470, 470, 220, 220 before powering it up. So we will. Goes without saying I've only got 15 minutes. I think it's those 2. I'm thinking wrong, it's that one. Well, it's somewhere. Is it that one? Yeah. Somebody's changed this capacitor. This isn't the original soldering. But here's the bonkers thing. This is still the awful type that is used in these sets. What they've done is they've taken that out of another one of these sets. Why would you do that? Known problematic parts swapped for known problematic parts. I'm sure you can find a scrap television set in the street and get a better quality one. Right, we'll clear up all those holes. I think that one was alright, but we'll do that anyway. Where's the fourth one there? So because we did the audio line 345s yesterday, it's funny how this goes, isn't it? You know, the same chassis sets consecutively, different customer. Right, I've still got the service manual out for the for this chassis, so that's handy because it's got a memory like a sieve. So it handily tells us which is positive and negative. And that lead doesn't want to go in. That took some wiggling. That's our first 470. These are all Nikon ones. They're all higher voltage rated. They're all higher temperature rated. I'll do that one later. Dread to think what that badly put in diode's all about. Diode 14 is there. I just don't know. Why would you put a 1 in 4001 in? I'm not going to unsolder it till we've powered the set up, but I hope it isn't making something like an 8-volt voltage rail more. And I've got to do this even if this set turns out to be a write-off. Okay, there's the other 220. Come to me. And of course we'll go over this with isopropyl alcohol, not just where I've soldered it, but where there's been other things. The other thing to do is to always check these chassis screws. You can end up with microphony, and on Tansmit you can end up with generating interference if they're not tight. I don't know who RV is, but they've scratched their initials. Right. So apart from some corrosion, on the aerial socket. Now it's come with, it's not come with a mic, but it's come with a power lead. I'll tell you what we'll do. Oh yeah, the power lead's attached to this Daft Echo thing. So 5 amp fuse is not what should be in the radio. Must be somewhere around 2 to 3 amps. I don't know whether I've got them on my bench. I've got 10 amp ones for business radios. And why is that, Mr. Tango? Because most of the UK business radios are 25 watts output. So they're normally going to draw around 7. We'll put this in for now, but it's something I'll have to address before it goes back to the customer. At least it's come with a bit of power lead, and that saves him some money, because it's otherwise it's a nice one. It's not a stupidly skinny one, and that looks like an RS fuse holder. It's certainly good quality, and just needs that fuse addressing. So we will connect this up. I will plug this into our speaker on the wall, because I've obviously unsoldered the normal speaker. We'll plug our Uniden test mic in. Try not to rustle too many things across the 4 microphones in front of me. There we go, 13.8 volts. And there we are, meters out. Displays out on 1 bar. Don't think we'll be doing anything about that. It's a matter of getting it working, isn't it, rather than a restoration when it's as full of nicotine as this is. Right, we need to connect to our test equipment and hope that we get some noise on receive. Tell you what, let's check PA first. That seems a sensible thing to do. Testing 1 2, testing 1 2. We don't have PA working. Of course, it's always possible some bright sparks rewired that mic connector, isn't it? Let's go back to CB. Jammed meter and it's transmitting. We'll start putting some parameters down. So we're on channel 20. It's on frequency, not that you can do anything about that. 2779132. Are we showing picture in picture? Should be. It's in the wrong position. So we'll just show camera 2. 2779131. That's absolutely fine. See if there's any deviation. Wallow. Don't think my walkie-talkie's here. I think I lent it Mr. Chippy. I'll put these instruments back on the perch because we had an avalanche of instruments when I took that base station off the bench. So we'll come back to that. Let's look at power on Tansmit. So I'll go to main meter. We're on the 3 watt scale. We've got full scale deflection. It's actually doing 3.9 watts. Channel 40, 3.7 watts. Channel 1, 3.9 watts. Back to channel 20. Our current consumption is at 895 milliamps. Mind you, it's not running a meter lamp at the moment. And low power. If I press the right button. No, can't I? Pressed low. I pressed dim, didn't I? If for some reason low power, instead of doing 400 milliwatts, is doing 1.29 amps. Watts. Meter's not working. PA's not working. Let's see if receive's working. So we'll put receive frequency in 2779125. Receive is absolutely as deaf as a post, but that could be RF gain. There we go. Now these aren't the most sensitive sets in the world, but we expect it to be about 1 microvolt. We'll need an extra earth on our speaker, and we'll just pop it on any can for an earth. Switch the instrument on, and let's have a look on camera 4. A not knock off. So at the moment it's receiving at 12 dB, 3.05 microvolts. 10 dB it's receiving at 2.4 microvolts. So it's as deaf as a post, isn't it? And does it ever do 20? It does do 20. Yes, folks, it does. It does 20 at 5, 6, 7, 8.8 microvolts. Squelch. Actually does open. It opens at 4.9 millivolts. So it's a bit strong. And if we drop down the squelch, turn the signal generator to standby, the squelch control's dirty, so I can't set threshold sensibly, so just give that a quick spray. I'm just tempted to do RF gain and mic gain. Volume seems to be alright. Let's put that back on. Work that around a bit. Set threshold, and let's show you the attenuator as to where we are. So we're on standby at 0.3 of a microvolt. So we've set threshold on the radio. Put the signal generator back on. See if the squelch comes in. It comes in. Minimum squelch sensitivity for the threshold position is 57.5 microvolts. So current range, I would say, is 1 mile on receive with the squelch. We will come to the VCO because it's been fiddled with, but I'll do that when I come back from lunch. What we will just do is see if we can go through the transmitter. It's very close, but it would be better if it was balanced that little bit better. So let's go back to camera 1. Part of me would like to do the receiver first to make sure that it actually is capable of receiving better than this, and it's just been, I think the phrase is farted with. I just hope that switch hasn't been repurposed. I can see a link there which I'm not expecting. Anyway, transmit. So here we go. I better put it on back on full power. So the peak, we're on the centre of the peak. That's there. Centre of the peak. I'll unclip that. They were spot on. That was tiny bit to one side. These look a bit mangled. Let's have a look. That now looks right. This particular example doesn't want to do 4 watts, but it may have had the airspace coils messed with. Well, that's a bit closer. No, I mean, he's 3.9 watts, whatever we do. Right, I'll go for lunch and see see you in half an hour. So we'll start with the VCO, and it is channel 40. The test point is resistor 54. Anyway, resistor 52, you see I'm lying to you, and resistor 52 is there, and when we go into transmit, I'll pop it on low power so we're not heating up the transmitter, which incidentally after me being away for half an hour is doing what? It's 3.9, so that's why it is. Yes. Whether you can see that meter, I don't want to have it on the right hand side. So we're looking at VCO for 3.5 volts. It's absolutely spot on. So that might have been messed with, but it's correct. And there's a check. Just need to make sure that channel 1 is somewhere we'd expect to be an in-lock voltage. So let's just check channel 1. It doesn't tell you to do this in the manual, but I will just check. 2.28. So that's fine. Well, would you believe that? I thought, no, that's going to have been fiddled with, but it hasn't. Or if it has, it's been done correctly. So it's what did it say? 3. It said it was 3.48. So I think we'll go. I'm going to have to try and unstick the meter, because when you set the detector, not the detector, the IF on these, it's very much beneficial to be able to see the meter move to make sure we're kind of the right side of it. And it, you know, with it being as deaf as a post, let's get ourselves an earth back on. We'll put it on one of the transmitter coils. And as far as no transmitted audio, chances are it's going to be duff capacitor down here, or the chip. So I'll get the receiver somewhere like, make sure we've got RF gain at full. Volume control is the only one I haven't cleaned, and it is a bit iffy, so that's another one we'll do. I don't need to do it this minute though. So let's switch to the oscilloscope. Have enough volume for a sensible trace. We'll just turn down the oscilloscope a fraction. There we go. See whether the detector's out. No, that's spot on. I'll just see if the IF is obviously out. Little bit on that, but not something daft. So just going back into transmit for a section. I don't need to show you this. Did I miss this one? Because I think it's transmit on these sets. I did, you know, I missed it, and that's why we're not doing 4 watts. That's come straight up to 4 watts. So we'll deal with that later. So used to doing cybernet sets, I missed that out. Alright, we'll drop the signal generator and put the SINAD meter on. And want about well, about where we are, I think, 4 dB. A bit more volume, just so you can hear it. And we'll run through the front end. But I need a big improvement for this to be anywhere near. That was spot on. That's spot on. What have we actually got at the moment? It's 3 microvolts. It's dreadful. See if I can unstick the meter. You know, it's things like this. What's that about? I've got one here. Which is the earlier version. That certainly hasn't got a diode there. And you see, it's in the receiver, this. Now this is the earlier version, but nevertheless, I'm going to disconnect one end because it's right in the receiver. You know, you don't know whether there's some local daft idea that if you put a diode there, it makes the bleed over better. You know, which by making it deaf would happen, wouldn't it? Just take one end out. And once again compare that other set. Just to make sure they haven't cut the print anywhere. Well, let's get rid of Mr. Blobby, because I mean that's a massive blob, isn't it? So, have they taken a part out just there? Well, it looks like they have, doesn't it? I don't mind leaving that, just get rid of that solder blob. No, there's no component. There is no component where that hole is. Let's turn the set back on. Just run through that section again. I'm just going to run through these just in case. No, I mean that's right. Yeah, it's still 3 microvolts. Why is that? Soldered to that can. I think it's going to be another not repairing video, you know. I think we're getting a spate of this at the moment. Let's see where this red wire goes. Oh, it's a meter lamp which has been tacked in on the back, so I can understand what that's about. One other thing to check. And that is the coil here, which is done at test point 3, but we don't need to do it at test point 3, we can do it on the SINAD meter because the radio is already sufficiently working. And that's virtually spot on. I'm just going to make, what I'm going to do, I'm just going to make the test set slightly off frequency, just to see whether we've got a crystal filter type of lopsidedness problem. So I'm going to, I'll keep that on the display, the SINAD meter, because as I change the frequency, it was currently spot on. I just want to see whether it gets better. We've gone up, it's got worse. No, it's not that. It's the time for the state it's in. Is if this was immaculate, just come out of a box and it was in this state, it's worth checking the filters, because we can take them out and change them by swap them over by substitution. That can cause a deafness problem. We can also go around checking all the capacitors in the receiver. Theoretically, it could make a difference. We can also check that every one of the transistors is at least the gain that is advertised to be. But all this is very time consuming on a very tired set. So even at minimum wage, we don't want to be having people with £65 bills. So I don't know. I think that's it's you know, it is a shame. So we've got no transmitted audio. Let's go back to PA. is that PA? Probably.
We now have.
Okay, right, we didn't have before. So, the fact that that's now come back, we need to change all those 4 capacitors if we want to restore that that function. I'll have a think about this while we do something else. The fact it's come back and we know it's going to be those capacitors. I'm just thinking, you know, if we go to all that expense, what I don't want is it to be the same and I've spent another 90 minutes on it. You know. I think we've got a better circuit. That's the Murphy. I think we've got a better circuit. But when you look at this, anything that can drag the voltage down, I'll have to look. I think I'll have to look on my computer screen, but I can't see this is going to be, because whatever we do, it's still going to have a bar out on its display and a meter that's stuck. So I don't want to start unjamming the meter if this set is a no-hoper. That one, 19 by the looks of it. I think that says 19. I mean, that could well be something which, that electrolytic capacitor there, if that was leaky, it would be making the signal leak to ground. So that's the kind of contender we're looking for. Let's see whether we can see capacitor 19. I'm expecting it to be around this area, which is the receiver. But I might be misreading the component number off the dodgy photocopy. I'll have a look at the circuit on the computer where it might be a little bit more legible. Well, good news, folks. I changed the 2 capacitors here. And it brought it down. We were at 3 microvolts, weren't we? And it brought it down to 2.95 microvolts for 12 decibel SINAD, which is still absolutely pointless and useless, but it did make a slight difference. And I thought, well, another thing that can play up in sets with crystal filters is crystal filters. So change the crystal filter for a brand new one, and we've got the right sensitivity back. Normally, when we've got poor sensitivity and it's not something obvious, then the first thing we go for is the filters, and both the 455 filter and the 10.695 filter can cause this kind of problem. So I thought, well, I'll try it. Again, it's an expensive part to change relatively. About a fiver, aren't they? And the danger is I wouldn't be able to recover it and sell it somebody else. So I'm glad it's fixed it. Right, so we've now got 0.95 microvolts with no further. I've not done any further adjustment. We're straight in at 0.95 microvolts, and that's exactly where we should be on this kind of radio. So I may as well now take the front off and carry on, because we've got a goer. So I can put my sample set back. We'll get rid of that diode. I have no idea what it's about. No doubt somebody will leave a thing in the comment that it turns it into something wonderful if you put a diode in. But there you go. But I don't know where this has been, but considering it's the later version. I say it's the scruffiest one I've seen. We won't be doing anything with the display. Doing displays is very time consuming, even when you've got the parts to hand. And to my mind, it has no advantage unless you want a radio for a shelf queen, and this radio isn't really a shelf queen when you look at its state. So we'll get this off. I will give, because I've got the front off, we'll have the courtesy of cleaning that. I'll probably run it through the dishwasher right now. That's lost that screw, so we'll have to find another screw. This floor will only get swept when I croak it. Oh, it doesn't come off like that, does it? Oh, it's like that, is it? Well, we won't be taking the front off and shoving it through the dishwasher. You know what? It's so filthy. I'll pause this because again, it's a lot of work. We've got to take all the securing nuts off. Right, so it's a lot of work, but we'll get this dismantled. So I've taken the front off, and as a courtesy, I'm putting it in my dishwasher because it's filthy. To be honest, I think we ought to take these buttons off if I can. Not sure if I can. You see, the difference is when it's my set and when it's a customer's set, I don't want to break anything. And while we're at it, I will just look if that subboard to the display is soldered properly and go over it with isopropyl alcohol. As I won't be changing the display on it, it's just too much work because you've got to unsolder this, and the chances are that the print's going to come away. So get the bulb out. I'll tell you what, I'll just put these in the dishwasher. So we're in a situation where it's got this lamp, which shouldn't be there. I'll remove that in a moment. And the lamp that should be there, which is melted. Right, remember black goes to positive, folks, just like you would expect. So you can see this is all melted, and that will be what's killed the meter. Wrong bulb. So the tape, the chances of getting this to work are slim. It's so melted, it's melted the innards. So you can imagine it's going to be absolutely awful. So can we get this out? Got these, got that off. Well, that's got it out. So next thing, is there anything we can do with the knackered meter? So sometimes we can ease off the lower bearing. most of the time we can't. Well, I mean, that has eased off, so I'll put the lid back on. I mean, the needle's actually bent, isn't it? Anyway, where did I put the lid? Please, it's not like you buy another of these sets to a scrap to buy it to get a meter, because they all have this meter problem. The Fidelity 1000 is the same meter, but it doesn't seem to be a problem in those sets. I hate to say this, but the Fidelity 1000s are actually worth more. I don't know why that is. People will pay a lot more money for Fidelity 1000 than they will one of these. Right, have we got any ohms? We have. Now, this doesn't mean that it's going to work. I'm going to go through the motions of putting a new lamp in it. And these are the right number of milliamps. Though we have to glue them in the holder. Mind you, what's left of the holder. I'm not even sure we're going to get that out without breaking it out. I'll try and push it out from the bottom. I think this is being glued in just like we're going to have to. Well, I've done it. There we go, we've got the bulb in. Now what I'm going to do, put that to one side, I'm going to now look at the soldering on this subboard, because it may not be a digit out on the display. It may be that we've got a duck bit of soldering with all the heat over decades. So ones I can see are okay, and some look absolutely dodgy. So all these look okay. That looks possibly dodgy, but it's not. That looks very dodgy. It's not. That looks very dodgy. It's not. There we go. But we're going to solder them up anyway. Even better, oh, if I could find where the solder's gone. So that's the one that looked dodgy, which are now dealt with. It can't be anything this side, because this side does the channel selection, this side does the display. We can power it up in bits. I think you'll all realise this has gone beyond a commercially economical repair. Right, let's get that power lead plugged into it. Power supply on. Still got exactly the same bar out, so that's where we are with it. Can't do more than that without changing display, which means getting a display. Right, well, we need to get rid of this extra lamp that somebody's put in. Turn the power supply off again. That's that one. And that's what that is soldered to that can. That's the other side of that knackered bulb. And one side of the bulb goes to the PA switch. And the other side, well, we'll find out, won't we? Now, while we've got this in bits, we may as well do these capacitors, because we've got intermittent audio. When it was cold, there was no transmitted audio, and so it's going to be these capacitors here. 95, 96. I think we'll start with those two. And that is also 4.7 microfarads. So I'll get those changed. Right folks, that's all put back together, having been through the dishwasher. I'll show you the front in a moment. I'll do the deviation. I've done the 2 capacitors, which I think it is in here. PA's working. I can show you PA working. Testing 1, 2. And as a precaution, overnight, I'll make sure tomorrow that the radio is still working on PA. So it's 4.7 microfarads, 4.7 microfarads, 220 microfarads, 220 microfarads, 470 microfarads. There were 2 others. 1 microfarad. I think that was 22. Meter lamp. Right, over to our, and I can see the meter actually working at the moment. Incredible. We'll just go over to our other deviation meter. We never did do the deviation on this one. It might be right, it might be wrong. Let's have a look. Wow, it says it actually says it's 2.4, and that would be absolutely super duper if it was. Right, I'll just plug into the other test set. Wow, it's a little bit high. It's 2.9. So where's my where's the normal tool gone? That's not the normal tool. Where's the normal glasses gone? They're not the normal glasses. Let's have a look. Wallow. Better just check my gains at full, hadn't I? No, it wasn't. Just pop a bit of service of switch cleaner on that, because it was coming and going. Wallow. That's 2.5. Wallow. There we go. Absolute peak of 2.5. It's one stupidly high, but wouldn't have been good to radios that were selective. Right. So I need to set the RF meter, which is showing. It's not that smooth, you know. This is all you can do. I don't think I'm going to try and set it any further than what it is. I think we'll leave it at that. And then on receive, let's get 100 microvolts on it. Signal meter, it's that one. Again, that's a bit of a dicky preset. You can see this has been in a smoking environment. This is what happens. So we've got S9. It doesn't go fully down. It does something, you know, it's better than nothing. And at least it's lit up. Right. Just going to go through the transmitter one final time. So it's now over the top. Remember, I forgot that that coil there was part of the transmitter, which is why we only had 3.9 watts. So I'll just see where we are on the other channels, which is kind of interesting without the knob. Channel 1 is 4 watts. Channel 40 is also 4 watts, so that's spot on. So 4 watts throughout. Now we've got this situation where low power was 1.29 watts. Let's go to low power. No, they're all dirty presets, these. That's 400 milliwatts. And our full power current consumption is now 881 milliamps with a meter lamp. So we've gone up a tiny bit, but it's tuned better, so we've got a lower current consumption despite having a meter lamp. Not, what was it? It was 2.94 amps, wasn't it, that President, for 4 watts? So we had 2.9 there. We've now got 2.2 to a maximum of 2.5. Frequency wise, it's not adjustable. I don't need to bother showing you that. It's 2779 140, 2779 140. Now everything's being warmed up. That is now working. Switches are okay. Potentiometers clean. That's what POT stands for, by the way. People, not everybody's aware. So all these presets are preset potentiometers. These are coils or variable transformers or variable inductors, and we'll just say coil number something. So when it's got a T designation, it'll be transformer. When it's an L, it'll be a coil. So they're variable coils and variable transformers. So variable inductors, but we'll just refer to them as coils. So there's today's tutorial. The sockets work. We don't know whether the speaker works. Now this receive. Just do the finalness. It's probably where it needs to be. That's 0.3 of a microvolt. I just want to, can I see that on the meter? No, because the meter sticks, doesn't it? Let's see if I can see any movement. No, we'll have to rely on the other instruments. It's that one that always worries me. Put a bit more volume on. I'll just look at the oscilloscope. Make sure our detector is still where we want it to be. And let's get a new SINAD reading. (12 dB, 0.92. It's exactly where you expect a Uniden set to be. I have seen them at 0.47, but that's like seeing a Cybernet at 0.19. 0.87 and 20 dB is 1.35. Oh yeah, crystal filter. And we just need to do the squelch now. So I want it to come into 100 microvolts. I'll turn the oscilloscope off and we will go over to camera 6. Squelch presets. Can we actually get this to come in any less. Or is it another dirty preset? Well, that's maximum sensitivity, especially if we've actually got that on. So full squelch is now more than I'd like, but it is not too stupid at 620 microvolts. And our sensitivity before, it was an unusable 57 microvolts. Let's just see where the squelch sensitivity now is. Put the signal generator to standby, turn the squelch down, set threshold, signal generator back on. Oh, that's still lousy. 5.5 microvolts. Let's just give another go at that. I'll just be a bit more careful setting threshold. Best I can get is 3.6. Not good. Right, we want the speaker lid. Let's see whether its internal speaker works. I'm going to twist these. That's another reason to stop hum. These don't suffer from hum, but you don't know what shenanigans have happened. I just hope this speaker works, because pretty irreplaceable at 16 ohms. Unplug the extension speaker. Hardly get a screwdriver into that, because the carpet tape they've used has done the hole. I'll have to do isopropyl later. Need to clean the board up, definitely, but we'll have to do that later. I'll go and get the other lid out of the dishwasher. We'll see whether we can hear anybody, and then we'll do an on the air test. But if this gentleman's used to Amstrad sets, I know he's got two, you'll find that Uniden set much less sensitive. I got rid of that die. I had no idea why that would be there. Certainly not in any other sets. It's not on the circuit diagram. The fact the meter moves at all is absolute bonus. There's no fee for that. We'll just try and do something like that for people. I'll have to go and get the knobs back, and we'll plug this into the aerial. Okay, so that's back together, and that we did put the top case in the dishwasher just as a courtesy. All the knobs are being cleaned, but it's a little less filthy than it was. One-niner Roger. Let's have a flick round. Well, there we go. It's as good as we're going to get at that, and what a job to make that work. Thanks for watching Uniden 200 late version. Resurrection from goodness knows what.